Hello, everybody. Welcome to part 4 of my income distribution series. In the first three parts, we have discussed how to, starting with a relative frequency table, how to generate a cumulative relative frequency table, how to draw histogram and ogive, and also how to calculate mean and median of such group data. We also discussed the gender pay gap, so we looked a little into issues of inequality. In part 4 and 5, we will discuss inequality further, and we will look at measures of inequality for the whole society. And in part 4, what we will do is we look at the Robin Hood, so-called Robin Hood index. So, for this part, what you need to know is how to calculate the mean of group data, and this is discussed in part 2 of the series. So please watch this if you don't know this. In terms of Excel, we will cover absolute referencing. This is indicated by this dollar sign in the formula. So we will discuss when a dollar sign is appropriate and when not, and the max and the min functions. All right, let's go into it. So remember again, this is a data we have. We look at income, the income distribution of Switzerland. So here is an example of female full-time employees 2020. We have the classes on the left. So for instance, 12% of all female full-time employees in Switzerland get between 3,001 and 4,000 Swiss francs per month. So this is the income in months in terms of groups and brackets. And here are the relative frequencies. So we start with this relative frequency table. And these two parts have been used for the mean. Remember, again, this is from part 2. Now, Robin Hood enters, and remember, Robin Hood, he takes from the rich and gives to the poor. So that's essentially what we need to do. We need the average, which is 6,209, and that means that these are the poor classes. So these frequencies here are the people in the poor classes, and then of course everything else is the rich classes. So the rich, which are here, give some money to the poor, which are there. So it's a very simple concept. And Robin Hood index just indicates the percentage of money moved over the total amount of money. Now, the problem with this approach is that the total amount of money is not known because we don't know how many female full-time employees we have in Switzerland. Of course, we could look this up. And so we need to know how much money do these 0.2% of the population make. And of course, we would multiply the amount of people in this class by the average income in this class. So remember again the midpoints, we discussed this in part 1. Actually in part 2. So the midpoints, we assume that everybody in this class gets just the middle point in this bracket. So we need to know how many people we have, but we don't know how many people we have overall. So what we do in such a case is we assume a certain number. So this is maybe an important trick in mathematics very often. If a number is not given and you think you might need this number to calculate something, then just assume a number, because either the number is really important for the solution, then of course you make something wrong, but very often the number is not relevant. So in this case also the number is not relevant. You can do everything without knowing this number, because eventually you will do ratios again. So that means if we want to make things a little more concrete, we just assume that we have 1,000 people. So 1,000 is a good number, I suppose, because here we have percentages with 0.2%. So 0.2% of 1,000 are just 2 people. So we go from the relative frequencies to the frequencies. And of course, this is an assumption here. Maybe I color this a little. to indicate this is something which is not true. We don't have 1,000 female full-time employees in Switzerland, but because the number doesn't matter so much or doesn't matter at all, we just can go on with this assumption. And then what we do first is we calculate the number of people in each class. So the persons, or maybe I call it the frequencies, because this is what we do. We go from the relative frequency table to the frequency table. So the frequency is obtained by multiplying the relative frequency by the amount. So we do this multiplication. Now, you see, we have two, and of course, this is the decimals. So the decimals, maybe we want to delete here, so we don't have 2.00 something people, we have just two persons in this class. So we round everything. Keep in mind, again, 1,000 is not totally correct, but it doesn't matter. So, ordinarily, if you have a formula like this, so you remember this is a formula blue times red, what we can do is we can copy it down this way, but this time it will not work. Well, why not? Because if we copy a formula down, look what we get. This formula refers to blue and red, and then if we copy this formula one step down, the references will also move both one step down. So you see it here. This one refers to the new blue one, which is just one below the old blue one, and the new red one, but the new red one is no longer the 1,000. So what we want to do is if we copy this down, we want the blue cells to move, but the red cells to stay. And this is called absolute referencing. So relative referencing means if you move a formula, then the references should move accordingly. That's the ordinary referencing we have. But for the F1 formula, I don't want the F1 to change. In particular, I don't want the 1 to change. And because I'm moving down, the F will not change anyway. I'm moving down. But the 1 would change into 2 if I don't do anything against it. What can I do against it? Well, I can pin this 1 by putting a dollar sign in front of the 1. So you see it here. I'm writing B4 times F $1. $1 means the 1 is pinned. And if I copy this cell down, this formula in this cell down, then it will always be F $1, but it will be B5, B6, B7, and so on. So that's the first Excel content for this part, absolute referencing. Okay, let me try to pull it down again. So what do? We pull it down, and here we go. You see, everything falls into place. Let me just show maybe one example here again. B8 times F $1, not F dollar something, but rather F $1. So everything is fine. And the sum of these persons in the group, so if I go to the auto sum again, how many people do we have totally? Well, we have 1,000. So this is not a surprise because that was our assumption. So we assume we have 1,000 people. We calculate the frequencies, we add them up, it's 1,000. So it really matches. Next, what I want to do is I want to calculate the total amount of money the people in the different groups make. So I call it amount. And the formula is relatively simple. I have two people in the first group. They get 500 each. So how much do we have in total? Well, it's a product of both. So we have, this one is equal to 2 times 500, or in other words, E4 times C4. And again, keep in mind, in this case, if I copy this formula down, the 4s should change into 5s and 6 and 7. So everything is fine. We don't need absolute referencing. We need relative referencing. So the ordinary is the usual one. So this is, and again, it shows the decimals, and the decimals I don't want. I just want to have it rounded into Swiss francs. So the two people, keep in mind, it is not really, this is not really two people, it's 2 point something. Again, we have this fractions, which is a little awkward because we cannot have point two people, but this will not change anything. So I take this formula, I pull it down, and up to here. And you see, of course, this first group has a very small amount, 1,000 francs per month. If you go to the groups which are very popular, I mean, 25%, 20%, so we have 258 people in this one, of course, they get, what is it, 1 million each. And then the numbers go down again, not because, I mean, it goes down because the number of people in the groups goes down very quickly, whereas the amount of money in for each person in the group goes up, but goes up less than the number of people decreases. So again, what is the total amount of money? We make the auto sum again. Again, Excel guesses the range correctly. And the total amount of money made by these people would be 6.2 million francs if we have 1,000 people. And of course, it's not a coincidence that it's just 1,000 times this value here. So 1,000 times mean would be the total amount. Maybe I make this italics to show a little that this is a sum. All right. So we have 6.2 million francs per month, assuming we have 1,000 people. And now we want to distribute, and it's pretty simple. So we have one column for getting and one column for giving. The poor get and the rich give. So how much do they get? Well, they get as much money until they have the average. What is the average? The average is here, the yellow one, 6,209. They get 500, but they need to have 6,209. So how much will each person get? Well, each person gets the difference between 500 and 6,209. But because we have two people, we have to multiply it by two. So the formula is the amount of money people in this group get is equal to the number of people in the group times, and then I'm opening a parenthesis because I look at the difference. And the difference is what? Well, the difference between the mean and so what they want or what they should have minus what they have. And this is a formula. Now, maybe I release it first and you see it's 11,000, so they get a lot. But let me go back into the formula. Do we need any absolute referencing here? Well, E4 is good because in the next class we look at E5. C4 is good because it should be C5, but D25 should be D25 throughout. So the 25 should not change. We should not go to this cell because this cell doesn't even contain a number. So that means I have to pin 25, so I put in a dollar sign in front of the 25. And again, absolute referencing again needed. This is a formula, and this is the amount of money people in this group get from Robinhood. So 11,000 are moved, then 19,000 are moved to this class. They get more money because there are more people. More money. And let me try to pull it down a little. And you see at some point we get negatives. So this class will get negative 41,000. So what does it mean? It means they don't get, they give. So what I really want to do is I want to erase these numbers because I want to do the sum of these movements at the end. So I want to erase this because if I would put it in, I would get some positive values, I would get some negative values, and the sum of all would be zero because the amount of money which is given is exactly the same, uh, which is getting to people. Actually, I just noticed here. No, it's all right. So they get. So this one is erased. So we look at this one only because this group. Um, well, this group does not get anything because they are too rich. They are 6,500. They have 6,500 and they should have the mean only. So they are giving. They're not getting. So that means at this part, we start with a getting and with a giving. And how much do they give? Well, it's 141 people. And how much does each person give? Well, it's a difference between what they have and what they should have after Robin Hood is done with them. So you see, it's essentially the same formula as before, except that I'm subtracting D25 from C10, and in the first versions I just looked at the opposite. And the 25, of course, must be pinned again. Absolute referencing here, remember the same issue. So we look at this number and we drag it down. And then here and here I want to have sums again. So maybe we do all these sums here in italics and bold, just to make it a little more obvious that you're looking at sums here. So what is the sum of these getting amounts? I click on the sum, go to this cell, I want to have it here, a little separated from the rest. I click on the sigma, and you see in this case, Excel is not very good telling what I want to add because it's so far away. So it says, do you want to add these three numbers? And no, it's nonsense. I don't want this. What I want to do is I want to add these numbers. And you see I have some empty cells. This is all right. Empty cells just count as zero. I want to add all these numbers here. And so, well, how much do all these people, the poor people, get? They get 1 million. It's 1 million. And how much do the rich people give? I'm copying this formula to the right, meaning all references are moved to the right. So I'm adding the age cell. So maybe I just double click on it to indicate again what we are adding. We are adding these here. And the result is the same amount as the other one. And that's not very surprising, I suppose. Robin Hood gives as much as he gets. Ideally, again, this idealistic Robin Hood just takes from the rich and gives to the poor. Nothing remains at Robin Hood's. Okay, that's all right. And then, of course, what we need to do is we need to make the ratio between how much is moved divided by how much is the total amount of money. So we make the ratio of these two values. But before we do this, let me just do one more thing on the sheet. Because this is the problem with the sheet so far and with the cells is if you put in other data, if you put in a different relative frequency table, then you might have only 5 poor classes, you might have 7 poor classes or 8 poor classes. So it's not always the case that the mean is exactly here. And it means you would always have to check where the negatives start and then move to the right. It's a little awkward. What I want to do instead is I want to have the same formula in all these cells here, but I want that the formula shows zero if it would be negative otherwise. And that means I want to display this result of the formula if it's positive, but if it's not, I want to display a zero. And this can be done by the so-called max function. So I'm going here right after the equal sign, and I'm typing max and open a parenthesis. This is a function The max function has the format equal sign max, open parentheses, and then a few entries inside the parentheses separated by commas. So we do a comma and we do a zero. So now we have two entries, and you see what I want to have is either this formula or zero. And I want to show the larger of one of both. So if this formula is positive, then it shows the formula. And if the formula is negative, then it shows a zero because zero is larger than the number otherwise. So I'm clicking return, and yes, I guess in my Excel, I need a semicolon. I suppose depends on the language setting. It's either a semicolon or comma, depending on the language. And then I put this down here, and I get zeros. And I'm doing exactly the same here. I'm replacing this one by max and going with this one, putting a semicolon and a zero. Again, zero, semicolon or comma. Check it out. And depending on whether you have a decimal point or and then I'm pulling this up, and we have zeros as well. And again, if we have only 5 poor classes, we will have a zero here automatically. If we have 7, 1, we have another value here also. So that means you will not have to change this template if you look at other years and maybe mail, other data. You don't have to change this. All right, almost done. What is the Robin Hood index? Maybe I put it, where do I put it? Maybe I put it here. So I say Robin Hood. And maybe I don't write index because it's just too long. So I just write Robin Hood, but I mean Robin Hood index. And I color these two. Again, I highlight it, maybe in orange or whatever. What is a Robin Hood index? It's a ratio, it's the amount of the relative frequency or the percentage of the total amount of money which is moved. So it's a ratio between this one and that one. So we are moving 1 million out of our 6.2 million. So how much is this? And I want to show it in percentages here again. Maybe I want to show one decimal. So my Robin Hood index for this case is 16.1%. 16.1% of the whole amount of money is moved. Okay, that's it. It was part 4, Robin Hood index using mean. In the next video, we will look at Lorenz curve and Gini index. Bye bye.